All right, so we're going to do the opener. Anybody know what number one? What's point slope form? Which one's point slope form? C is correct. C is correct. Yeah. So I use a modified point slope form. So did anybody remember that one? Because I don't think we got it over in this class. So I'm going to move the y1 to the very back end. So we were going to rewrite this as a y equals instead of a y minus y1. So you'll see y equals, and then you'll have your m, and then you're going to do your parentheses, and then we'll do the x minus x1 plus y1. This is what we call transformation form, okay? So this is the form that we'll use when we're doing transformations. So it'll make it a little bit easier because I can stair step you into those transformations pretty easily using this. All right, so now I'm going to go with slope-intercept form, which is A. All right, slope-intercept form really is what it is. The slope is your letter M, and your intercept is your B. So in this case here, the B, if I was going to write an intercept, it would be 0B, would be your y-intercept. Whatever that number in the back is, your slope-intercept form, right? So I call this SI form, slope-intercept. First one would be PS, and the last one would be SF, which is B, which is your standard form. Okay, so we had to write these equations, okay, and so anytime that we're writing the equations, this is actually the format you want it in. You want to start with, in this case here, point slope form, then we're going to go to slope intercept form and go to standard form. So if I ask for you to write an equation in standard form, you will always start with point slope form first. Because you only need two items in order to write an equational line, a point and a slope. Okay, so those are two things you need. All right, so you need a point and you need the slope. Those are the two things that you need in order to write an equation. All right, so write an equation in point slope form that passes through this point. Well, that point would be x1, y1. All right, and then with the rate of change of -2. So m is equal to -2. So now I have a point and I have a slope. And I'm going to use, again, I'm going to use this equation. So I'm just going to go write down y equals -2 parentheses x minus 2 minus 5. Now it would be like a plus minus 5, but you don't need to write it as a plus minus because when I'm plugging in the -5 right there, I don't have to do it. Okay? Then we're going to graph it. Well, guys, this is how far right you go. This is how far up or down you go. So you're going to go right 2, down 1, 2, 3, 4, 5. Your slope is -2 over 1. Again, that would be your rise over what? Run. In this case here, I'm going to go down 2 and then to the right 1. So down 2 to the right 1. Or you could flip it and you could have 2 over -1, which means that you would go up 2 into the left 1, up 2 to the left 1. Now, I have a lot of people who would draw these dots and they'll just leave it like that. And that is not the line. The line is where you connect the dots. Okay? So that is writing it into point slope form right there. There you go. Now we're taking a look at number 5 right here. Write an equation in slope-intercept form. It passes through 2, -3 with a rate of change of 3. Again, we need a point and a slope to write. Now, I'm looking for slope-intercept form. Now, remember, the intercept has to be written as 0b. Is that written as 0b? No. So, therefore, we're going to use point slope form again. If you don't remember point slope form, it is y equals m times x minus x1 plus y1. We have a quiz on Friday. Your quiz is over your basic linear stuff, just like we're going over right now. Okay? The formulas are not on the quiz. All right? Anybody read Harry Potter or seen the movie? Okay, if you haven't, okay, so he gets in trouble. Well, there's this mean woman, Dolores Claiborne. So she's horrible and evil, and she doesn't like Harry. And every time he says something, she thinks he's lying. So he had him write with a pencil like 1,000 times, "I will not tell lies." Okay. Now it's a special pencil because it opened up a wound on the back of his hand. It says, "I will not tell lies." All right. And so he wrote that over and over and over again. Okay. And the more times he wrote it, you think he remembered it? Yeah, scarred on the back of his hand. Okay. So the more times you write down this formula, the greater chance you're going to have it remembered. Okay. You might have a social security number you got to memorize. If you don't have it memorized, write it down 10 times a day. You'll know it by the end of the week. Okay? Just burn it when you get done. Don't let anybody else have that social security number. Okay? So, what I'm trying to say is every single time I get to an equation, or when I have to write a problem down, I'm writing this equation down. Okay? So, here we're just going to plug in the rate of change, which is 3. Did you get a pencil? If you need pencils, I have a couple left over in the cups over here. There's a pencil sharpener there. There's some erasers in the hey. Do you guys know what hey means in Polynesian? It's chicken. You ever seen Moana? Hey is the chicken, and his name is Chicken. It's pretty funny. It's like, no, I mean, let's say, Knox, if your name was Human, it'd be kind of funny. Like, what's up, Human? You know, like, he's a human. But it's, I thought it was. All right, so so if you need items, I'll get more pencils over there eventually. All right, now passes through this point, we're going to make that x1, that y1, and we're just going to plug it into this. So x minus 2 plus 3. Well, in this case, it's going to be a minus 3 because that's a minus. That is not in slope-intercept form. All right, remember slope-intercept form is y equals mx plus one number, which is b. I have 2 numbers over here. Now, I can't just put those together because I have a grouping symbols. You remember this thing? PEMDAS. Please excuse my dumb blank sister. Okay. Is that right? Oh, wait, how'd you hear it? Oh, dear Aunt Sally? No, it was dumb blank sister for me. I mean, I had a sister. If you don't have a sister, yeah, like your sister, yeah, Gracie. All right, so, but this is grouping symbols. So you want to do that first. And then exponents, and you multiply and divide in that order from left to right and add subtract from left to right. Okay? So you just got to remember PEMDAS. So, grouping symbols. In this case here, that means I need to distribute here and here. It gives me 3x minus 6 minus 3. Then I will put these together now, which gives me what? Negative 9. Now I am in SI form. I started with point slope form and end up in SI. Okay? If I want standard form from here, I have to go from SI form into standard form. Okay? Now, if I'm going through this, 2, negative 3, 2, negative 3 is right here. My slope is up 3 over 1, up 3 over 1, up 3 over 1. And I can just draw my line. Down 3 over 1, down 3 over 1. I should have 0, negative 9 on my paper. Oh, look at this. That is my y-intercept. My y-intercept is 0, negative 9. I must always write my y-intercept as a what? Ordered pair. It must be written as an ordered pair. Any intercept is written as an ordered pair. Otherwise, you just give me a number. All right, so write the equation of the line in slope-intercept form. So I want you. We're going to go through these together, and in our notes today, our notes are very similar to this. So when we're doing our notes, I will pause. I'm going to let you guys work on these. So make sure you can do these. All right. So we're going to write the equation in line this line in slope-intercept form. So what do we start with? Point-slope form is correct. So point-slope form is, again, what? Y. Anybody? M. There you go. That is your point-slope form. Now, do I have the M? I'm given 2 points. Do I know my slope? Can you find your slope, Addison? Addison says, yeah, I can find my slope. I don't have it. I can find it. How did you find it, Addison? Okay, so she did something visual, which I love it because there are people who are visual learners. So she went over here, went -2, +3. She drew a point. She went over here, 2, 5. She drew a point. And then she did the little, oh, well, I'll just count up and over. So she rose 2, ran 4. So she found the slope to be 2/4, right? And that would give you 1/2 once you kind of slim it down a little bit, right? That's one way of doing it. Anybody else have another way? Yes. Yeah, so you can do the old formula, y2 minus y1 all over what? x2 minus x1. That works as well. Now, this is the way the middle school, and this is the way the formula is actually set up. It does not matter if you went and had your numbers like 1, 2, 1, 2. If you couldn't remember if it was 2, 1 or 1, 2, they just need to be consistent. You can't have 1, 2, 1, 2, and the other one 2, 1. That switches them. But you can switch those around if you want to. All right, now, so that is I remember this, and this is the way I do it. Very similar to that, I do the change of y. So m is equal to the change of y's over the change of x's. So change means how far apart they are. Okay, Lily, how far apart is 3 and 5? It's a distance of 2. So I'm looking at my y's. I know it's a distance of 2. All right, you got that? So now, Ian, I'm looking for the distance between my x's. How far apart are my x's? 4. So that's giving me a slope that is 2/4. Now, finding if it's positive or negative on that slope is an issue when you're doing it this way. But I always say just need to be consistent. If anything's swapped, then it's going to switch the signs. So take a look. If I'm looking at the number line, and I was putting 3 and 5 on the number line, so 3 would be here and 5 would be here, correct? So 3 would be on this side and 5 would be on this side. It goes from left to right. Where's -2? Well, -2 is over here and +2 is over here, which is also left to right. As they're always going from smaller to larger, then you're going to be consistent. It's going to be the same. If one of those is switched and one is going from left to right and the other one's going right to left, then you're going to have a negative slope. All right? Or Addison, you can just draw it on a graph and see that it is a positive slope because it's going up. Okay, because it's going up. All right, so my slope in this case is 1/2. I gave you 2 different ways you can do it, or several different ways you can do it. I don't care which way you use. Just master one of them and use it. Okay? You don't have to solve the same problem the same way. All right. So x minus, which point do I use? Annie? Which one? Yeah, you can use either because they're both on the line. They're both on the line. All right. So which one do you want to use, Annie? The first one, we'll just call that one x1, y1. That works perfectly. So I would just do a -2 all over here +3. Yeah, and I just said minus means what, Kevin? Positive. So you can just, in this paper here, just going to make that a plus sign. You're now in point slope form. Again, this is point slope form. I've got to change it into SI form. So what is your next step, Abigail? Distribute. So the 1/2 goes to each of these. So I'm going to get a 1/2 x, and 1/2 of 2 is 1, and I'm going to add it to 3. And if I did my math right, I'm going to get 1/2 x plus 4. 3 plus 1 is 4. Ta-da! Now, if you noticed, what do you notice about these points and these points? It's the same equation, right? 6a, 6b, we just made it the same. So now we're going to change this into standard form, Bailey. So do you remember how to change anything to standard form? I'll go change 1/2 x plus 4. What's standard form? It's at the top of the page. Nope. Standard form. Yeah, so we wanted to write it like this. Now, so there's something special. It's the ABC equation in our math for lines. Now, what's really special is A must be positive, and the whole equation has to have no fractions. This is the way we have it at Dobyns-Bennett, all right? In the University of Dobyns-Bennett, this is the way we do it. The standard form can be different at different use institutions, okay? So at that ETSU, they could have it negative in fractions in the front if they wanted to. They're just going to tell you the format, all right? This is our format. All right, now, so looking to do some work here, Lydia. So I need to do what with this 1/2 x? I need to, well, this one is x. Wow, that's right. I need to move it over is correct. Which is kind of like making it on the other side. So I'm going to subtract 1/2 on this side and 1/2 x on this side. So I get 1/2 x plus y is equal to 4. Now, we have an issue here, okay? Mary Beth, our issue is that that is negative and has a fraction. So how do you get rid of the negative, Mary Beth? So she wants to multiply by -1 and 2 at the same time, which would be multiplying by -2. So we could just multiply this by -2 to the whole thing. The reason why she got the 2 is because it has a what? Fractions, the denominator. The common denominator is what we need. So we're going to multiply by -2, which is beautiful. So we're going to multiply by -2 to each of these. So -2 times a -1/2, the negatives go away, the 2's go away, I just get x. The -2 times the y gives me -2y. And then -2 times 4 gives me a -8. That is now in standard form. Okay? You may have any questions. Correct. So you can multiply by 2 anytime you want to. So if you want to multiply by 2 here to get rid of the fraction to begin with, you would have gotten 2y is equal to x plus 8. So you would have started there. Then move the x over, and then had to multiply by -1. Works beautifully. Doesn't matter when you remove the fractions, you can move them anytime. Okay? That's a great question. Any other quick questions? Yes.
When you have a negative number, like y for instance is -5, would you change the minus to y plus 5?
So you would have y plus 5 equals -2 times x minus 2.
Yeah.
So this is what yours would look like. All right, so I accept either one of those. Okay, so if you were taking the quiz on Friday, I asked for point slope form, and Kaylee says, hey, I'm going to write it like this. Kylie says, oh, well, if it was Kaylee, but it's Kylie in this class. If Kylie says it like this, it's good. And if Alex's brother says it like this, it's like that. Okay? You guys know Peyton's brother, Alex? I don't know, but that's Peyton. I got it figured. I knew that. Yeah, I'll accept either. So what your question was?
I thought you were asking, so I might change
So on the other side, yes, when it started, it was what, y minus 5, right? And that would turn into a plus. So just combine that in and make that a y plus 5. Yes. Okay. Any other quick questions? All right. Moving on, let's take a look at our homework. I'm going to have you guys go to the board. You are paired up. Your partner's next to you. If I can get it to show up. All right, so just quickly write these up on the board. Let's do this for you can number 1. Just go on that board. You guys you do number 5 on the backboard, right there. And how about you two? The rest of you guys, I'm gonna come around and take a look at your work. You should have number homework 0.1 done.
Do we need to do the draft too?
Do what?
Draft too.
Yeah, just kind of draw. I mean, no, I think that first one you can go ahead and write the equation.
Just do ABC.
Yeah. Oh, yeah, you can graph it. Yeah, actually, graph it. So these are all graphed there real quick.
Yeah, because
This one here, you're going to draw. Get your homework. Yes. You have to create. What I would do is write that this one starts at -4. As it moves forward, this one, I don't know. I've seen people do it like this, but it's less than equal to, less than or equal to. It's just like that. We don't.
Okay, so just do this.
Yeah. All right, so I am recording this. And one thing, when you go through the class recordings on Canvas, because I'll post it there to YouTube, and it'll be a blank time, but you'll hear our voices and just hit 2 times the speed or just fast forward. Okay. So if you happen to be sick or if you want to rehash anything that you missed, you have an opportunity to go back and review it. Okay. If I make a mistake, you can, I guess make a meme out of it. My baseball. All right, so. Yeah, you good. Okay. So we got to put parentheses, right? And plus 0, plus 2. Yeah. All right. Let's see if we got any questions here. I know you're finishing up back there, but that's all right. On number 1, again, I always want to start with point slope form, and so that's where I always start with. I've got my slope and I got my point, so I'll just go through this one with you guys. So this one here would be y equals 5 over 2 x minus 0 plus 2. That's what I've done. Okay? Now, I need to distribute to 5 halves over, put it in slope-intercept form, distribute, and then add. Well, 5 halves times 0 is 0, so this equation just ends up being 5 over 2 and x plus 2. Ta-da. Standard form. Standard form, we're going to take this one right here and write it in standard form. Now, what was the pattern we did earlier? What did we do with the slope in the x there? Lydia had said distribute, but we really want to take that and do what? Yeah, subtract to the other side, okay? So we're going to call that subtracting. So we're going to subtract 5 over 2 on both sides. 5 over 2x plus y, so y, is equal to 2. Now, remember, standard form is the ax plus by equals c. So we're trying to get it in that. So now I have xy, right? Have the xy equal sign. That was kind of cool. All right, now, so I need to change it into a positive and no fractions. As last one, we had a negative sign in the front, so Mary Beth told us we need to multiply everything by a negative. And then we had a 2 on the bottom, so we want to multiply by a 2. So we're going to multiply every one of those things by a negative 2. So when I do that, that makes that a positive 10 divided by 2, which would be just 5. Remember, the 2's cancel, so I get 5x, positive 5x. Then I distribute the negative 2 for that. I get minus 2y. And take the negative 2 times the 4, which gives me negative 4. So that should be my standard form, right? Which is what they have over there, all right? So here's my standard. Good job. What are you confused on? Yeah, standard form is probably the toughest of them all, okay? But again, what it is if you can get to this right here is the form that we use. I'm going off script, guys, on the camera there, but y equals mx plus b is here, correct? Standard form, again, is written as ax plus b, y is equal to c. So every single time we have to move this over to that side. So we have to subtract the slope and the x. That's what you're doing. And then I'm going to have a plus y is equal to b. Then at the time, that's when you're going to multiply by a negative, or if you need to, because that can be a negative slope. It depends on what those numbers are. But that's all you're doing with your slope-intercept form. So it is just kind of, now I have it really close, all right, to that form. So it's just, in this case here, it's not It is just moving the mx.
What is that?
Yeah, so it is it's probably the toughest form for most students in here. Okay, it's getting to that form. All right.
Why
So
is it plus 2 when it's plus 2?
why is it what?
Why isn't slope intercept form it's plus 2, but what's that?
0, 2 is mine. It's my y-intercept. It should be here. All right. And then my slope. Then I'm going to go down 5, 1, 2, 3, 4, 5 over 2, and it's right here. Then I'm going to go up, right, and then slide. Now, some of you guys would think that the x-intercept is at -1. It's not, okay. My x-intercept is going to be a little harder to find for that one. I don't think it asked that question. So. If I want to find here real quick for number 2, I need to find my domain and range. So this is some of the questions I've had today in A block, and I just had it earlier. When I'm looking at my domain, I'm looking how far left to right I am going. Domain is how wide the graph is. How wide is a line? I think, Colton, how wide is a line? Infinite. Now, so there's 2 ways you can write it. Now, we can say all reals. You can actually write the word all reals. There is a number that we do here, a symbol that we use, and it is 2 lines with the R symbol. I call it a double bar R. Right? That means all reals. Now, we're going to use this thing called interval notation. And interval notation is where we go negative infinity all the way to positive infinity. Okay? So, you can write it as either one of those. Most students just go dun, dun, dun. And lines always go up and down forever as well. So, if you have a line, it's just going to be all reals all the time. Okay? Really, really simple. Slope, most people have no problem. Rise over run, they know the slope. X-intercepts, Y-intercepts. Guys, X-intercept, the Y is 0. Okay? Y-intercepts, the X is 0. It must be written as an ordered pair. You will have a quiz on Friday, and if you don't know that, you will lose points for not writing them as ordered pairs. You cannot just write down 2 or 1. Those are just numbers. They're not ordered pairs. So, my x-intercept in this case is -1. Notice that's where the x-intercept is on the x-axis. The y-intercept is 2, 0, 2. Okay? Questions on that? All right. So, number 3. Number 3. Is this a function? No. Why is it not a function? Yes, x values repeat. Now you can use 1, 1, 1, -1, or 4, 2, and 4, -2 to identify those. All right. So which one was the, in this case here, the vertical line? The left one. Good job, people. All right. Let's see here. Let me slide over. Does anybody have any questions on number 5? You feel like you can do those?
I can get 33 over 2.
Okay, which one? On A or B? On B? All right, so f of 3/2. That's this one going into this equation. So I would do f of 3/2 is equal to 1/2 times, because that's an x, 3/2. Okay, you know what to do now, Elijah? What do you do with the top numbers? You multiply them, and you multiply the bottom numbers. You do not have to find a common denominator when you're multiplying. It is just the tops times the bottoms. Okay? If I have 5 times 7 over 3, that is 5 over 1. So that would make that 35 over 3. So again, you multiply the tops and the bottoms. That makes sense? All right? And we'll talk about division when we come to one, but we don't have division yet. But it's just keep, change, flip. It's Kentucky chicken fried. Okay? Everybody loves Kentucky chicken fried. Well, okay. Some people like it. Oh. This finger looking good. I grew up on it. All right, number 6. Domain and range. How wide is a parabola? It is infinite, so that would make that all real numbers. Again, if you write from negative infinity, this goes that direction to negative infinity. It goes to the right to positive infinity. You could write it like that. That is what we call interval notation. You will. You need to learn that. It's probably the easiest of them all, to tell you the truth. Now, Alex's brother's Peyton over here, he showed me an inequality, and you can do this with an X. You just got, all you have to do is make sure that this is the largest infinity, and then this is the smaller infinity. You have to like, so you could write it like this, okay? You might see it written like that in Math Excel or some of the state exams, but we try to stay away from it that way. But my range, all right, we're doing my range, Katie. What's my range for this one? Greater than or equal to -4. That's what she said. That's the inequality. That is acceptable. How did she figure this out? Well, range is from bottom to top. So you're going from your bottom to the top. The bottom of this graph, it doesn't go any lower than -4. -4 is the bottom of the graph. So I usually write it like this. This is how I do it. Peyton, I put a -4 down. Then I notice it's going up forever. So that means the top of the graph is infinity. So the bottom's -4, the top is infinity. Infinity is not an exact number, so it gets a parentheses every single time. -4 is exact. When we go over here, -4 is included. That is not a dotted line. It's not an open circle. So that means -4 is involved in this. So in order to do that, you have to create a bracket around this. Okay? A bracket kind of reminds me of equal to. So when we're saying greater than or equal to, Kate, then I'm thinking of a bracket in my mind because it's an equal to symbol. Okay? Where a parentheses is a nice curve, right? Where it's not exact. So had this been a parabola that was dotted like this, then it would be -4 like that. So it would not include -4 in the picture of your domain. Okay? So that's for future that we'll be talking about when we're doing piecewise statements. Any other questions?
Back to that, like if it's like flipped, like where it's up and down, we can just switch -4s.
Yeah, I like it. So if you had it flipped, and let's say we were at +4 and we had it flipped at +4, the range in this one would go from -infinity all the way to 4 is correct. Because in this case here, your bottom is -infinity and your top is 4. Now, guys, look where -infinity is. Where's -infinity? On the left side, correct? When you look at a number line, where's positive infinity? On the right side. Where is -infinity? On the left. When you're writing an ordered pair and you put -infinity over here and positive infinity over here, are you correct? No, it goes from least to greatest when you do an interval notation. You flipped it over, okay? Sometimes maybe we'll have, opposite day, like they did in SpongeBob, okay? But not today. All right. So on those opposite days, you can call me Mr. Haight or Coach Haight. Yeah, I grew up on SpongeBob too. Well, my kids did. I watched all the episodes up until like season 6, and then they changed. I tried to eat a waffle on the beach in Southern California. So I tried to eat a waffle on the beach in Southern California. It was a San Diego. All right. I tried. San Diego?
It's a beach, but I don't know.
It's a city.
Oh,
No, San Diego's a city.
a waffle.
A waffle, Eggo, Lego, my ego. Oh, sorry. I guess it wasn't that funny if I had explained it. So, all right, one more. All right then. All right, we'll give you another one. Oh, Kate, do you know how to knock jokes work? Knock jokes work? All right, knock. I guess she doesn't know how it works. So yeah, I usually say what? Knock. Olive. Yeah, that's the way it works, right? So in that case here, when I said knock, she said, who's there? I said knock, and she just says knock, who? Knock, like knock. Yes.
Wait, so what's the rest? Where's the rest of it?
It's supposed to be knock, and I say knock,
You say it.
and then she says knock, who?
Why did you three?
Because I'm knock, and not Oliver.
Does it add up?
There you go.
No.
That's what was so funny about it.
Right.
I said, all right, you start the joke, Kate. Go ahead.
Knock.
Who's there?
Knock.
Knock, who? See, that's the way it works. All right.
Knock, and then you're supposed to answer. Aren't you supposed to say something after that?
Let's just say knock.
No. You can't just like knock you say it, and then you answer. It's supposed to be a joke at the end.
The whole joke is not really a joke. All right, no. So, which award was given to the inventor of the knock jokes? He got the Nobel Prize. He got the Nobel Prize. There's no bell to ring, so you had to use the knock. So all right. So why did the woman get fired from the calendar factory?
Why?
Because she took a day off.
Wow. That wasn't the first one.
Right? It's 29 days instead of. All right. So she got fired. Yeah, I worked when I went to school in Florida, and I worked at an orange juice factory. I was pressured. They kind of squeezed me out because I couldn't concentrate. All right, let's switch gears. Let's go to our notes. All right. So I did find this when I was moving rooms. I did find this old relic here. Do you know that they're not making these any longer? They're always going to be 12 inches. They're not making them any longer. All right, so we stopped here, somewhere in here. We didn't get very far, right? We're at number what?
The second row.
6? Example 6? Example 5. All right, so to evaluate means what we're going to do is we're going to plug in. Okay, we're going to plug in that value. Now we're going to write it as a complete sentence. To write a complete sentence, you must have the equal sign. So we're going to F of 2 is equal to 3 times 2 plus 1. Okay. Now you will show your work. All right. So 3 times 2 is 6 plus 1 is 7. So we're going to get F of 2 is equal to 7. Now, I want you to understand that this was a line that we started with, right? We have a slope and we have a y-intercept, and we can graph it, and we can find a location. of that point, when we plug in x, which is 2, we get y is 7. So 2, 7 happens to be the input-output. It happens to be a point on the graph. Okay? So go ahead and do number 6. Let's see how you do. You're just going to take the -3 and you're going to plug it in. Yes. Have a kiosk system. So yeah, you can write it as an order pair. It's not necessary. You don't have to. I just showed you that it was like in this case here. I just want you to understand what it is. That you're actually finding an equation. You have a line. You're putting x in, and you're finding an output, which is a y. So you're actually finding an order pair, which is what you really. It's just fine. It's perfect that you did that. It depends on what the question would look like. So here I got -9 plus 1, right? So I got -8. So f of -3 gives you -8. Okay? All right, going on down here, and we are going to have fractions in this class. You're going to love fractions. Or actually, you're not going to love them. You're just going to get better at them. We start off in this here, starting off fairly easy, and we will get more complicated as we get into quadratics, which will be sometime around Thanksgiving. All right, now, so let's take a look at example number 7 so we can deal with that fraction. You guys, or you just do f of -1/2 is equal to 3 times -1/2 plus 1. And as I showed Elijah earlier, which he just left, you're going to put a 1 over that 3, and you are multiplying. So there's no common denominator involved, so you multiply the tops, which is -3. And you multiply the bottoms, which is 2. Now, I'm going to add it to a 1 over 1. And I went ahead and changed that 1 into a fraction, because when I add fractions together or subtract, I must have a common denominator. All right? This is halves, and this is wholes. I have to make sure they're both equivalent in the denominator in order to happen. So, to change that 1 to a 2, you just multiply. If you multiply the bottom, you must multiply the top, because you're not allowed to multiply by anything other than 1. And 2 over 2 is really 1. So I'm not changing the 1, just making it look like 2 over 2. Now I can add them together. -3 plus 2. I add those together, gives you what? -1. And the denominator stays the same. It still halves. So the answer to this one, f of -1/2 is equal to -1/2. Yes. That point would look like this. -1/2, -1/2 would be somewhere in here. Because this would be at 1 right here and 1 right here. So it would just be a half. All right, 3/5. F of 3 over 5 is equal to 3 times 3 over 5 plus 1. Again, you can put that 3 over 1 if you want to, and you're going to multiply the 3 times 3, which is 9, and that's going to be over 5 plus 1 over 1. But we want to make that a what? 5 over 5. Now, add those together gives you 14 over 5. So, yep. Yeah, do not change it into a mixed number. I do not want it written as 2 and some change or whatever, okay? It will always be written as what we call an improper fraction. You always have a larger number over a smaller number is what we call improper fractions. And you must do that because the higher you go in math, that's the way they're going to write it. We don't use mixed numbers anymore. All right, moving along. Now the next one is just showing you here on example number 9 and 10. I'm gonna leave it to you guys to do, but all it's asking you to do here, okay, is notice the letters. This is the F, goes with the F, and the G will go with the G, okay? So I'm going to skip those and move on, and we're going to go to linear equations. Now, we just went over point-slope form, we went over slope-intercept form, and we went over standard form. So I'm going to give you a minute or two to write those equations down, and work number 11 and 12. So go ahead and work number 11 and 12 on your own. If you want to go ahead and do the other ones I just skipped over, the 9 and 10, you can do that real quick as well. And then we'll come back and we're going to do, before we leave, we're going to do parallel and perpendicular lines here in just a minute. Oh, yeah, okay. They want you to write it. I would take the opportunity to write it. So when I'm doing this is a hint for those. When I'm doing this problem right here, yeah, I want it written with these. Remember, standard form is the last thing you're going to look for. So these are kind of backwards. So this point slope form is where I'm going to start. Now, before I get started, I'm going to write the point slope form that I want to use. I'm going to write it with the letters first. I'm going to write this one in the formula, right? I'm going to write this one as a formula. I know you can copy it. You're basically copying it from the other page. I want you to write it down. The reason why is because, again, the more times you write it down, you're going to remember it. And you have to have it memorized. They're not going to be given to you on any piece of paper. So. All right. So I'm going to go quickly over this. Anybody found the domain range yet? All the numbers. X-intercept. 2, 0. And 0, 2. Slope. M is equal to -1. I think it's falling, so it's negative. Point slope form. I'm just going to go y equals -1, x minus 0 plus 2. The next one, y equals -x plus 2. Standard form. I have to move the x over to that side. X plus y equals 2. So guys, what? There it is. Give you a second to double check your work there. Write any notes you need to. If you made a mistake somewhere, this is the opportunity to make sure you understand what you need to write down. Again, these you refer back to when you're doing your homework. So I've got the questions. If you got questions up here and ask me why and what is different and why do I have that versus this, I'm going to try to explain it to you. Okay? Yes. Number 9. I'm going to go over that real quick. Example number 9, I'm going to take this, I'm going to plug it into that equation. So f of 2 over 3 is equal to 2 over 3 plus 2 over 1. So here I'm going to write them as both fractions because I'm adding the fractions. Now, Peyton, I've got to make this a 3 on the bottom here, which means I need to multiply by 3 because I'm multiplying by 3 over 3, which is really 1. So that will make that 2 over 3 plus 6 over 3. All right? Now, the 3 just tells me that I've got them cut into parts of 3. I'm going to add the 2 and the 6 to give me the total number, which is 8. So then I give f of 2/3 is equal to 8 over 3. Okay? Do not write that as 2 and 2/3. I don't want it. All right? Usually like that. Any other quick questions? All right. Moving on to number 12. Yeah. So when we're doing notes and you're going over notes, the one thing is that, again, this is your opportunity to color it up, highlight, do whatever you want. You know, this is when you get your pen bag out and you just like go to town if you got that type of stuff. This is the time when you write that stuff and you make notes to yourself. Oh, I should be plugging in here. You know, like this is an opportunity I gave you to do it and you messed it up. Then you go, wait a second, I made a mistake here. Watch out for this. This is what you write down. When you get to college, there's nobody telling you, okay? The professor's going to give it to you, and they're not going to be there to really help. Now, Northeast is a little bit smaller, so you can visit with the professors and get things figured out there. But larger institutions like the University of Tennessee, they're not going to know your name unless you make them. All right, now, domain. Anybody know what this is right here? If you graph that, what is that? What do we call that? It is point slope form, but what are you graphing, Elijah? What does it look like when you get done? A line. And a line has what as a domain and range? All real numbers. So you could just automatically go, oh, all reals. All reals. You know what I'm saying? So here, you know if it's that there it is. Now, what form are we in number 12? Point slope. So in point slope form, then we need to say, oh, wait a second, the point is 3, -1. So I go over 3, down 1, and my slope is down to right 3. or up to left 3. Okay. Now, because I have this, it's really simple. Remember, my x-intercept, my y is 0, and the y-intercept, my x is 0. So it's really easy since these actually fell on really nice spots. That one's right there, and, well, that one's not a nice spot. We do have the y-intercept, right? Which is 1. So how are you going to find the x-intercept? Take this 0, which is your y, and plug it in right there. This is where you're going to say plug in. 0 for y. That's how you find an x-intercept. So 1 equals negative 2 over 3x minus 3. What do you want to do now? How do you solve that equation? Distribute is one way of doing it. So if I distribute the 2/3 here and here, I'm going to get 1 equals negative 2 over 3x minus 3 times negative 2 over 3. Now, Peyton, I showed you earlier, take the fraction here, you can put that over 1, correct? And you can multiply negative 3 times negative 2. What's negative 3 times negative 2? Negative times negative is a positive 6. So this is going to give me, this side over here is going to be a positive 6 over 3. This is going to be negative 2 over 3 is equal to 1. So what's your next plan? Who likes fractions? Lily loves it. So can't ask Lily this question. But do you know, Lily, how to get rid of those fractions? By 3 is correct. If we multiply everything by 3, then all of the fractions go away. So I'm going to get 3 equals negative 2x plus 18. I messed my math up somewhere. It looks good. All right. So I'm going to subtract the 18, right? What do I get here? Equals negative 2x. And then what? Divide by negative 2. There's something wrong with this. Because that's giving me what? Oh. It was a... That's a 6. Thank you, thank you, thank you. I knew there's something wrong. Right here it is. It's not an 18. You're correct. It's 18 divided by 3, which is 6. Correct. All right. So I'm going to subtract the 6 from both sides. So I get negative 3 is equal to negative 2x divided by negative 2. X will equal 3 over 2 when you get done. Does that make sense? Because where's 3 over 2? Anybody know what 3 over 2 is as a decimal? 2 will go into 3 one time and a half, so 1.5. Guess where I am right there? I'm at 1.5. So that is the intercept. All right, real quickly here, let's run to, just slide over. I know I got about 5 minutes, but let's talk about parallel lines. If it shows up in your homework, you know how to do it. You got 6 minutes. Parallel lines. What do you know about parallel lines? Same slope. What else do you have? Different y intercepts. That's correct. What do you know about perpendicular lines? Yeah, almost. Opposite reciprocals. So we're going to have opposite reciprocals. All right, example of this. -5/3 is your slope. Your perpendicular, this is the symbol for perpendicular. Slope would be m, would be equal to 3/5 is correct. Good job. Excellent. All right. So we're going to do the opposite reciprocals. So we'll do different types of equations. So let's go through here real quick and do number 14. All right, in number 14, it says find the slope-intercept form of a line that is parallel, that's the symbol for parallel right there, to this, that passes through this point. Kate, what do you need in order to write an equation of a line?
Is that the question mark on our? We have two question marks. We don't have the parallel.
Well, it would be parallel. So write the word parallel right here. That's what that's supposed to be. All right. So, Katie Egan, what would you need in order to write an equation of a line? Point and a slope, which means that you should have what then? Point slope form, which is y equals m times x minus x1 plus y1. Okay? I already have x1 and y1, correct? I need the what? The slope. With parallel lines, you know it's what? Equal to this one. It's the same as this slope. What form are we in? Pretty close to standard form other than the negative sign. So how would you find the slope of that? You could change that into y equals mx plus b. That is one way of doing this. And most students would do that. They would move the x over and get 3y equals 2x plus 8. Then what?
Would you have to multiply by the negative?
No. You do not have to change the sign to do this. You can divide by 3 on each of those. So y would equal 2/3 x plus 8/3. Now you know that the slope is 2/3. So you would put 2/3 right here. All right. And then I'm going to get x minus x1, which is minus 2 plus 6. So that ends up being a plus sign right here. And that is your point slope form. Now we can change that into slope intercept form here in just a minute. But we're running out of time. I'm going to show you real quick. Because I got this minute here. Here's your standard form, correct? How would I change it into slope intercept form? I'm going to subtract the x over, so I get by equals negative ax plus c. Then you would divide by b. I divide by b. So what is m going to equal? Negative a over b. And I always remember this because b is on the scale and negative a is a little higher than that. And so if you use this is a quick way of finding your slope if you're in a standard form. So this is standard form. What is the opposite? Anybody know what the opposite of negative 2 is? And then you have it over b. So 2/3 happens to be the slope. There is your slope, 2/3. If you're talented enough to remember that, it'll make it really fast for you. Okay? You don't remember it, I'll go over it again tomorrow. Maybe you will. Woo. Second day of school. We already learned about parallel lines. Crazy. All right. So when you're out there, just make sure you don't run into each other. Stay parallel to the hall. Okay. Yeah, they're on the phone.
No, it's bad. It's actually bad. It should not be that. Like, It's right.
Well, part of it is, I think when we did our scavenger hunts and we toured the school with them, nobody was here, so they all went.
Anytime freshman.
So we probably need to get that as an etiquette.
There's way too many. They need to start doing fields and stuff. Like so.
See you tomorrow. You want tonight? Yeah. That way you can have it there. It will be there tomorrow.
No. Yes. I'm like,